Hi everybody, welcome to day 16, section 2.4, quadratic functions. Today we're going to look at a standard form of a quadratic function where we'll be able to identify the vertex, which direction the graph opens up. Is it narrower or wider than our mother function? And we'll also complete this square to get it from our quadratic function to our standard form. All right, so just a real quick reminder that a quadratic function of x is a function that can be represented by the equation in this form, where we have ax squared plus bx plus c. So then here are all the different ways, plus many others, of how you might see that written. Our mother function, that's this guy right here, where we have a vertex of 0, 0. It opens up, okay, and it looks just like this guy. So now we're going to kind of get into it and compare the two. So if we scroll on down to this box here, here's what we're used to. F of x equals ax squared plus bx plus c. That's our quadratic function. And you have seen this standard form, or we've called it vertex form before, where it's f of x equals a times the quantity x minus h squared plus k. So our vertex is hk. If a is positive, we're opening up. If a is negative, we're opening down. And we would say we're wider than the mother function if the absolute value of a is less than 1, or narrower if the absolute value of a is greater than 1. And we're also going to talk about this axis of symmetry, which is a vertical line that goes through our vertex at x equals h. Okay, so all of this you have seen before, but it's just a reminder. All right, so let's go ahead and get into some of these examples down here where I want you to quickly state the vertex for each quadratic function and then determine if it opens up or down. Will the graph be narrower or wider or the same width as the mother function f of x equals x squared? So let's go ahead and start with example 1 here. Okay, so the first thing we should be able to do is identify our vertex. So our vertex is hk. If we take a look, our vertex here is 3, 2. We essentially take the opposite of what's inside. We have to compensate, and we keep that outside value of the plus 2. Okay, so which direction does this open? Well, you first have to identify your a value. So in this case, a is 1, so therefore it opens up. Okay, is it narrower or wider or the same width as the mother function? Well, if we take a look back up here, we can see that the a value is also 1. There's no coefficient, so therefore it's 1. So therefore it's the same width as the mother function. Okay. All right. So if we take a look at example B, identify your vertex. So we should be able to say that our vertex here is -1, 1. This time a equals -2. Therefore, it opens down because it's negative. Okay. Is it narrower, wider, or the same? Well, now I'm just looking at the absolute value of -2, which is just 2. And 2 is bigger than 1, so therefore we're going to say it's narrower. Okay. All right, really quickly, go ahead and fill out C on your own. Okay, you should have got the vertex to be 0, -5. A is 3/5, so it opens up, and it is going to be wider than the mother function because the absolute value of 3/5 is less than 1. Okay, all right, let's go to the next page and talk about transforming it to vertex form or standard form. Okay, so now we're going to find the standard form of a quadratic function by completing the square. So this is something we've done before, okay? But it's going to be a little bit different because we're only working on one side of the equation. So let's go ahead and get started. Okay, so we are going to just rearrange some things, okay? So we're still going to have f of x here. I'm going to put a blank, okay? And I'm going to scoot the -5 over a little bit. And then I need another blank. Okay, so we are going to work on one side of the equation this time. So we have to keep it balanced. So that's something to think about, okay? So remember how we completed the square before is we took this middle term, we divided by 1, and we squared it. So when we do that, we take that middle term, -2, we divide by 2, so that's -1, and we square it, we get a 1, okay? But since we are working on one side of the equation, we have to compensate. So since we added 1 to keep it balanced, we then have to subtract 1, okay? So we completed the square here. Sorry, there we go. Complete the square. And then over here, we have to add the opposite. Okay? So now, when we get this into our standard form, we're going to have f of x is equal to, so now we're going to factor the x squared minus 2x plus 1, and we get x minus 1 squared, and we clean up this -5 plus -1, and we get -6. So here is our standard form, or our vertex form. So now we should be able to identify the vertex, which is 1, -6. Our axis of symmetry, I call AOS, axis of symmetry, is the vertical line that passes through the vertex. So a vertical line passing through the point 1, -6 is going to be x equals 1. All right, so now we can go ahead and graph this. So if we create the table of values, and we put our vertex right in the middle, 1, -6. And now we choose some values that surround it. Well, we could choose 0, -1, and then 2, 3. What we should identify really quickly is when x is 0, if we go back to our original, we can easily find that when x is 0, y is -5. And because a quadratic function is symmetric about the x-axis, we know that 2 also produces -5, okay? When we plug 3 in, 3 minus 1 is 2, 2 squared is 4, 4 minus 6, we would get -2, and which also means when x is -1, y is also -2. So now we can go ahead and plot these points really quickly, and we'll go from there. So we have our vertex of 1, -6, so it puts us about there. We're going to have 0, -5, and 2, -5, and then we have 1, -2, and 3, -2, and now we can go ahead and draw this in. And if we wanted to, we could go ahead and draw that axis of symmetry, which is this vertical line passing through that vertex. Okay? All right, let's try this next one. All right, this next one isn't going to be so pretty because that b value of 7 is not even, right? So we'll have to see what we get. So let's first rearrange it. F of x is equal to x squared plus 7x plus a blank, move the plus 2 over a little bit, and then we have another blank for compensation, okay? So what goes in this first blank? Well, remember, we take 7, we divide it by 2. So 7 divided by 2 is just 7 over 2. And when you square that, square the 7, we get 49. Square the 2, we get 4. So 49/4 goes in that first blank, but we have to compensate. So whatever we add, we have to subtract. So this is going to be negative 49/4. Okay? And now when we go through and we factor and get it into our standard form, we're going to have f of x is equal to, we'll have x plus 7/2 squared, and cleaning up that plus 2 minus 49/4, it turns out to be minus 41/4. So the vertex isn't all that great, but it's doable. We can at least identify everything. Okay, so our vertex is the point now negative 7/2, negative 41/4. Okay, our axis of symmetry is that vertical line, x equals negative 7/2. Okay, and if we were to fill in the table and go from there, all right, to graph this, our vertex of negative 7/2, well, that's negative 3.5. And negative 41/4 is negative 10.25. Okay, so we're going to kind of estimate where that is. And then we can always look for our x-intercept. So when, or sorry, our y-intercept. When x is 0, what do we get for y? Well, when x is 0, we'll get 2. All right, so that's 3.5 units away. So if we go 3.5 units in the other direction, we're at negative 7, 2. Okay, so then honestly, those are probably good enough. So if we just go ahead and plot these points, we'll have a good idea of what this graph looks like. So we're at negative 3.5, negative 10.5. So that puts us off the grid just a little bit, which is all right. Not the best scenario, but no big deal for now. And then 0, 2, and negative 7, 2. And now we can go ahead and draw in the graph. And you can throw the axis of symmetry in there. Okay. All right, I want you to stop the video and I want you to try the last example on your own and then check back. All right, this is what you should have gotten. Pay close attention here. We had to factor out this negative. Okay, so that changes the sign here, which means we add 4, but really we added negative 4 because of this negative in front. So to compensate, we have to add 4 to the end. Okay, and when all is said and done, this is what we get for our standard form or vertex form, which opens down and we can see the rest. All right, so the rest of the time you are working on day 16 homework. I'll see you tomorrow.